We have seen linear inequalities before. Is anything coming to your mind? Well, how about this? What is the difference between a linear equation and a linear inequality? So if we have a system of linear equations, in two variables, x and y, I'll say in a system of linear equations, the solution is simply the point of intersection. Good. We know inequalities have infinite solutions. So if instead of having a system of linear equations, I ended up having a system of linear inequalities in two variables again, it is an intersection of regions. In other words, when we had linear inequalities, we had a line, we shaded above the line, below the line. Now, if you have two of them, you would have a shaded area that is overlapping for the two lines or between the two lines. That's what we mean by intersection of regions. That intersecting part is called the solution region. So, my first equation, y greater than or equal to x. The second one, y greater than or equal to negative x. We'll take that equal sign away in the second inequality so that we can see the difference. On the graph, what does y greater than or equal to x look like? We always started with a line, correct, when we graphed a linear inequality. And then we looked at the sign. If it had an equal sign, we drew a solid line. If it didn't have an equal sign, we drew a dashed or dotted line. So for a moment, if I assume this to be y equals x, what would that line look like? How many points do we need to draw this line? 2. Give me an easy number.
0.
0. If y is fine too, but 0 is easier. So if it's 0, y is 0. If it is 1, I get 1. So the first one is simply y equals x, and it is an increasing line that goes through the origin. Should I draw a solid line or a dotted line? Solid, because I see equal sign over there. Not bad today. Then we move on to the second. But before we do that, let's do the shading part. So greater than or equal to, we counted for the equal to part because it's a solid line. So where should we shade? That way, this way, above. Good. Now we move on to the second equation, or inequality. For a moment, I'm going to assume that y is equal to negative x, so that I can identify what the line looks like. Give me an easy number.
2.
0. So y is
0.
1, negative 1. So that would be a decreasing line. So
Where did you dot it?
thank you. I can easily make this dash.
And then is it opened up?
Yes, that is correct. Oh, you guys are paying attention. It's a good thing. Okay, now should it be above or below?
Well,
Above, because we have a greater than sign. So what is the overlapping region? It's right here, right? So yes. So all of that line works. Can I include points on this line? No, because of the dotted line. And that would be my solution region. So any point over there or on that solid line would be a solution. So think of waffles, right? The common area. Now I'm hungry. So the intersecting part looks like waffles. So we have y less than 3x minus 2, y greater than 2x plus 1. Both lines have to be solid or dotted. Both of them dotted because we don't have an equal sign. We'll start with the one on top. Easy number for x. 0, we get negative 2. 1, I'll have 3 minus 2, which would give me 1. Good. So 0, 1, 2. Oops. 1, 2. When it's 0, I have minus 2. So I'm going to put an open door. When it is 1, we get 1. And dotted line. Okay, should it be this way or that way? Below or above? Below, because we have a less than sign. So all the y values would be below this line, 3x minus 2. Good. The next line is, or inequality, is 2x plus 1. So for a moment, I'm going to assume that the line is equal to, so that I can determine the points using which I can connect the dots. So when I plug in 0, I get y to be 1. When I plug in 1, I get 2 times 1 plus 1, which is 3. Good. Should I put open dots or closed dots? Open. So when it is 0, we get 1. And when it's 1, we have 2. We want to connect it with a dashed line. Is it 3?
Yeah.
Okay, we'll just change this to 3. It's too late. Okay, so now should the solution be that way or this way? Above. So where is the solution? Is it here?
No,
There?
no,
There?
no,
There?
no. Yes. Yes.
Can't be on the line. So everything right in the middle. So that would be the solution. And just like a regular linear inequality, a system of linear inequalities would have infinitely many solutions. Now this is going to keep on going, so if you keep on going, there is this triangular area, that will be your final solution. Are we clear? Okay, so for a minute, I'm just going to write it as linear equations so that I'll know what the two lines are. Then I'll pick easy points. Well, we already know 1 point, yes? For each line, what is that 1 point? -4 and 1, y. Those are the y-intercepts. So for the first line, be -4. I'm going to put a solid dot because there is an equal sign. We just have to find another point. So let's plug in 1. If x is 1, 5 times 1 is 5. 5 minus 4 is 1. So 1, and I will have 1. So that is our line of y equals 5x minus 4. Should we shade to the left or to the right? Y is less than or equal to 5x minus 4. This way or that way? The second, we know one of the points, which is 1, so that is right over here. I shouldn't put a solid dot because it's a greater than sign, so I'm just going to put an open dot. When I plug in 1, I get 3. 2 times 1 is 2, 2 plus 1 is 3. So open dot over here. And it is greater than, so you don't even have to worry about shading here, but I'll start right there. So the intersecting part will be right here. Good. Okay. So when we intersect in a problem like this, typically you would get a nice little shape, a polygonal shape. You'll get 4 corners, just like you do. No one got that. You know, there's a place called 4 corners. Before we start graphing this, what should we do? Move the x to the other side. So y greater than or equal to 3. And y plus x. Y less than or equal to move the negative to the other side, 2x to the other side, it becomes negative 2x plus 6. One line is increasing, the other is decreasing. We are going to assume an equal sign so that we can draw the line. We already know 2 points. What are the 2 points? We know the intercepts. So for the first line, it is 3. So when x is 0, y is 3. For the second line, when x is 0, y is 6. We just need another point. So vertices happen typically when you have less than or equal to or greater than or equal to in both equations. So in other words, both of them end up being solid lines. Those other types of problems when you have vertices. So that's what we have here. I'll plug in 1. When x is 1, what is y? 4. The next line, 4 again. So the point of intersection happens to be at 4. So when x is 1, y is 4. The other line, when x is 1, y is 4. One line is going up, the other is going down. Yes. So let's see if you can visualize this. So this line is y equals negative 2x plus 6. And that line is y equals x plus 3. And we are graphing less than or equal to negative 2x plus 6. Greater than or equal to x plus 3. Good. So where do you think the overlapping region will be at? Left? Over here? Okay. So greater than or equal to for y equals negative 2x plus 6, less than or equal to. What is the overlapping region? What? It has a nice little shape like it. What does it look like? A diamond, a triangle, right? So the overlapping part is right here. Do we agree? So in 3 dimensions, perhaps a diamond has a triangular shape. So I can't draw a solid line because both lines are solid. So what is that point? That point is 0,3. Yes. What is that point? That point is the point of intersection for 1,4. And what is that point? That point is 0,6. Good. So the 3 corners in this case forms a nice little shape, and the solution region is every single value inside the edges and on the lines itself. As I mentioned, in most cases, when they ask you for vertices, they would have greater than or equal to equal sign in both inequalities. So what are the vertices? That point, and that point. Good. By all means, vertices are just fancy names for corners. Good. Are we clear? Okay. Looks like if you assume for a second that it is y equals x, then it's just a straight line that goes through the origin. Less than or equal to x, so we're going to shade everything below. The second inequality, we can't do it directly, we have to manipulate it a bit. So the first step would be to move the x to the other side. So we have minus x minus 20. Yes? Divide by 4 on both sides. So I went around, the common mistake was not dividing that x by 4. Just because you hate fractions doesn't mean you should ignore that 4. So minus 20 divided by 4. So negative x over 4, what is negative 20 over 4? Negative 5, correct. So we know one of the points, which is negative 5. So 0, you get negative 5. Plug in an easy number other than, 0, because we know what happens when it's 0. What is another easy number that you can plug in? 4, who said 4? Why 4? What would cancel each other? So you'd have 4 and 4 will get cancelled. You'll have negative 1, negative 5, which is negative 6. Closer to a flat line, but it's not a flat line. So everything below . And that is the point of intersection, right? My graph is not that great. I don't think it came to the exact point. So where is the point of intersection and the overlapping region? The region over here is the solution reached right there, right? How do we find that point of intersection? Well, we have the two equations. So x plus 4y equals negative 20, and y is equal to x. If the graph can give you the point of intersection, great, but I don't think it's giving me the exact one. So if I plug in y equals x, substitution method, I'd have 5x would be equal to negative 20. Divide by 5 on both sides, I will get negative 4. Yes? X is negative 4, y is also negative 4. So clearly, it's a poorly drawn line, way off. So that point of intersection is negative 4, negative 4. Good. It doesn't match up because I didn't draw things to scale. With me? Good. So the point of intersection is negative 4, negative 4. And the region is over here. So there is only one vertex because the others are going toward infinity and negative infinity. So that one vertex in this problem is negative 4, negative 4. Good. So what is the very first step? Rewrite the equation. One of the inequalities is easy to graph. It is that one. The other two are the ones we need to worry about. So first one, x minus y is less than or equal to 2. Move the x to the other side, negative y is less than or equal to 2 minus x. What is the next step? Divide by negative or multiply by negative 1, depends on how you see it. When you do that, this becomes y. What happens to the sign? It flips. Negative 2 plus x. So the first equation or inequality is y greater than or equal to x minus 2. So when it is 0, we have negative 2. When I plug in 1, I'll have negative 1. Yes, because I'm assuming the line is y equals negative 2. Excuse me, x minus negative 2. And when I plug in 2, I'm going to get 0. So that is my line. The first one. Greater than, so everything goes this way. Good. Okay, so off to the next one. X plus y is less than or equal to 2. Move the x to the other side. Y is less than or equal to 2 minus x. X becomes negative x. So we have negative x plus 2. Now that is a decreasing line. So the y-intercept is at 0. We need to plug in an easy point. What point should we plug in? And y equals negative x plus 2.
0.
We already put 0
1.
1. So when we put x is equal to 1, we would have 2 minus 1, which is that. And of course, when x is equal to 2, I am going to get 0, correct? 2 minus 2, 0. So the second line passes through badly through those 3 points. And x is equal to -3 would give us a vertical line, and then we can draw that inequality. But before we do that, this is y less than or equal to -x plus 2. So should we draw above the blue line or below the blue line? Below. Okay. And lastly, we have x is equal to -3, right? X is equal to -3 is a vertical line. Which I'm not drawing properly. Okay. And it is greater than or equal to -3. So what should we do? We've got to draw it this way. Yes. So do we know the region and the vertices? One is very obvious, correct? Which one's obvious? You can just point it in the graph. Is it here, here? This one. This one is an obvious vertex point. And this is the overlapping region, correct? So this line, when it goes up there, it is going to intersect. And this line, when it goes this way, it will intersect. Do you agree? So we just need to find where those two points are. Well, this line is going to intersect the vertical line, x is equal to -3. So does the second line. So to find that point of intersection, all I have to do is plug in -3 in both those equations. Do you agree? So if I plug in -3 here, I get +5. So as this line, decreasing line goes up, it intersects somewhere there outside of the whiteboard at x is equal or y is equal to 5. Good. Now, in a similar manner, this line is going to intersect right there. That is our common region, that triangular part. So you plug in x is equal to -3 in our equation here, the increasing line, y equals x minus 2. So -3, -2, we have -5. Yes? Where do the two lines meet? Or what is the other corner? The other corner is right here. And you can identify it at the very beginning, 2,2. Down, that's that. What is that point? 2,0. 0. Okay. So the first vertex is 2,0. What is the next one? Up here? Right, -3,5. What is the next one? Down there? -3, -5. Can you think of anything else? No, right? That's the shape we get. Good.